Hey everyone, so happy Monday. Today we are talking about lenses. Okay, so when we did these original drawings, we were talking about mirrors and how light reflects. Now we're talking about lenses where light refracts. Okay, so light's going to continue to move forward, it's just going to be bent. Okay, so lenses are all over the place. You all have lenses in your eyes. Okay, contacts, sunglasses, regular glasses, all of that. Other examples, if you have a nice camera, okay, this is a lens. Okay, the light comes through and it's processed. Your phone has a lens to take pictures. All of these things are lenses. Okay, so today we're going to talk about how light travels through a lens and how it bends. Okay, so when light goes through a lens, okay, it does obey Snell's law. So that's what we talked about last week. Okay, but it also does very predictable things with these drawings. So we're going to be drawing these three pictures. Okay, just like mirrors, these pictures are very similar. Okay, some good news. Okay, when we're doing this math, the equations from the mirrors still apply. So when we're talking about the relationship between focal length, DO, and DI, we still have 1 over DO plus 1 over DI equals 1 over the focal length. Okay, that equation still applies. The other equation that still applies is magnification. And magnification is still negative DI over DO. Okay, so you don't have to learn any new equations for this right here. Okay, now the first thing I want to do, okay, just like mirrors, there are two types of lenses. We're going to start with the easier one first. Now, the easier mirror was concave. Fortunately, the easier lens is convex. So we are going to draw our principal axis. Okay, make it as straight as possible. We're going to draw a lens. So a lens, okay, is double-sided because it's see-through. We can see through it on both sides. Okay, it is double-sided. So make sure when you're drawing this, it's double-sided. And that means there are two focal points. Okay, because there's a focal point for this side and there's a focal point for this side. So we have to draw in not only one, but the second focal point. Okay, so make sure you're doing that. Now, we're going to talk at first about the easiest drawing, which is when your object is outside of the focal point. Okay, remember you can draw whatever object you want. I can only draw arrows, so that's all I draw. Okay. Now, just like before, there are two main lines we have to draw. Parallel through the focal point parallel. Okay, so we're going to start with parallel to our principal axis into our lens. Okay, now a mirror, the light bounces backwards, but this is a lens. It refracts but continues to move forward. So the light continues to move forward and it goes through the focal point. Okay, the second one is focal point, then parallel. So you're going to line up the top and your focal point, okay, and you're going to draw until it hits your lens. Now, let's say like me, you didn't draw your lens big enough. That's fine. Just draw your lens bigger, okay? So through the focal point, and now this one goes parallel. Okay, now look, they intersect. Our image, okay, starts at our principal axis and goes to where they intersect. To the top of the arrow goes down. Now, 3 words to describe this. Inverted, it's upside down. Smaller, you can see it's smaller, and it's real. Okay, so inverted, smaller, real. Okay, I'm going to give you some math. Let's say the focal point is 20 centimeters, and your distance for your object is 60 centimeters. I want you to find DI and magnification. So pause the video, find DI and magnification using our two new equations. Shouldn't say new equations, they're old equations, okay? But here's what you should get. You should get DI equals 30 centimeters and your magnification is negative 0.5. So just a reminder, if this number is positive, it's a real image, just like what we found, okay? If magnification is negative, it means it's inverted, like it is. And if the absolute value is less than 1, it means it's smaller, which means that's what we got. Okay, so we did a good job. Okay, I'll be posting the math to this in case you didn't get these numbers. Make sure you look at it, okay?